And in this lesson, we're going to learn about the law of cosines. Now, if I have a preference, I would say that the law of cosines is my favorite, especially if you enjoy algebra. If you like ratios and cross-multiplying, law of sines is probably going to be more your style. But you do have to be able to do both. So law of sines was the last lesson, and now we're going to learn about the law of cosines. Use law of cosines in cases where you cannot use the law of sines. So for example, in this triangle, we would not be able to use the law of sines because we don't have a given ratio. We have a side angle side. So we would not be able to use the law of sines. However, we are given a ratio. We have side A and angle, we don't have a side A, so we cannot use the law of sines in this one because we have side, side, side. So the law of cosines can be used when we have a side angle side or a side, side, side information given about a triangle. Of a side, side, side. So we can use law of cosines when we have either case. They are very similar, so once you learn one, you can kind of pick up the other two. So the first one I like to start with is a squared is equal to b squared plus c squared minus 2bc cosine A. So it's kind of like Pythagorean theorem, except for you have the minus 2bc cosine A. So the way I think about it is that you have the b squared and the c squared, and you have the bc here, and then whatever you're starting with over here, a squared, that's the angle that you use. So the other form, if I start with b squared, I'll have a squared and c squared here. I'll have minus 2ac here, because that's here, and then I'll do cosine of angle B because we're starting with side B over here. And our third form would be the c squared, which means that we would have a squared and b squared over here. We would have minus 2ab here, and because we're starting with the side c, we'll have cosine c there. So those are the three different forms of the law of cosines. The first thing you want to do is solve for the side that's opposite the given angle. That's the first thing you want to do. And then once you have that, you're going to solve the angle opposite the shorter side using the law of sines or the law of cosines at that point. You can find the last angle by subtracting from 180 degrees. Let's say we want to figure out what C is. Okay, so we have a side angle side, which means we're going to use law of cosines. So we're going to start with c squared because that's what we're trying to solve. So we have c squared equals a squared plus b squared minus 2ab cosine c. So now we're going to fill in our given information. So our a, which is going to be across from angle A, is 16. So I'm going to plug in 16 here. And then b, side b, is across from angle B, so that would be 25. That will plug in here. Minus 2ab, so 1625, cosine angle C. And angle C is across from side C, so it would be cosine 78. I will put all of that into my calculator, making sure that I'm in degree mode because we're dealing with degrees. And then I will square root that answer, and I get the solution 26.7 for side C. So I'll plug in the information that I know. So remember, side A is across from angle A, so that's 16. And I'm going to square it, 16 squared. And side B is across from angle B, which is 25, so it'll be 25 squared there. And in side C, we solved for that in the previous slide, and that was 26.7. So it'll be 26.7 squared. Minus 2 times BC, so 2 times 25 times 26.7, cosine of angle A. And remember, angle A is what we are angle A is what we're trying to solve for. So I will go ahead and simplify as much as possible. I'll find out what 16 squared is. I'm going to subtract 25 squared. I'm going to subtract 26.7 squared, and then I'm going to divide by -2 times 25 times 26.7. And then I'll have an answer that's equal to cosine A. And then to undo the cosine, I will do the cosine inverse, which you can do that on your calculator by hitting second cosine. And then that will give me angle A. Rounding to the nearest tenth would be 35.9 degrees. And these are the steps you should want to follow. So the first thing you should do is solve for the angle opposite the shortest side. And once you do that, you want to solve for the angle opposite to the medium side. And at that point, because it's the second one that you're doing, you can use the law of sines or the law of cosines. Angle. This one, we're going to start with finding angle B because it is opposite of the shortest side. So we'll start with angle B. So the only form of the law of cosines that has angle B in it is the B squared equals A squared plus C squared minus 2AC cosine B. So we'll plug in our known values. So B is 4, so that's why we have 4 squared here. A is across from angle A, which is 10, so 10 squared will go there. And then C, which is across from angle C, is 8, so we have 8 squared here, minus 2 times A, which is 10, times B, which is 8, cosine angle B. And remember, we're trying to solve for angle B. So I'll go ahead and simplify everything. So I'll do 16 here. I'm going to subtract 100 from 16, and then subtract 64 from that, and then I will divide both sides by -2 times 10 times 8, and then I'll do second cosine of that answer, and then I will figure out that angle B on my calculator is 22.3 after I round to the nearest tenth. Okay, and then to find angle C, I'm going to do angle C next because it is across from the second smallest, or the middle side. So 8 is bigger than 4 but less than 10, so that means that side C, and 8 is side C, which means I want to solve for angle C next. So the law of cosine form that has angle C in it is C squared equals A squared plus B squared minus 2AB cosine C. So I'll plug in my information. 8 squared, since C is 8, equals 10 squared, since A is 10, plus 4 squared, since B is 4, minus 2 times 10 times 4 cosine C. And then I'll simplify. So I'll do 8 squared minus 10 squared minus 4 squared divided by -2 times 10 times 4. And I'll do second cosine of that answer. And then I'll end up with 49.4 after I round to the nearest tenth. Angle, I'll do 180 minus the 22.3 that I got from my first angle that I solved for, minus 49.4, which is the angle that I just solved for, and that gives me angle A, which is 108.3. Looking at this triangle, decide if you would use the law of sines or the law of cosines. So you should have picked the law of sines because you are given one of the ratios. So notice that the angle 16 is across from the given side 3. So you're given a side and the opposite angle, which means you should use the law of sines. A corresponding side with a corresponding angle, which means you would have to use law of cosines. Okay, so for this one, you are not given a corresponding side with a corresponding angle. So you have an angle side angle, which means you would have to use law of side. Oh, I'm sorry. You can actually solve for angle C, and then once you know angle C, because it would be 180 minus 16 minus 50, then it would be law of sines, because you would have angle C and you would have side C. So that is a trick question. So make sure you're watching out for that. So this would actually be law of sines. Because the angles will never change, however the sides can. So for example, when we use 30, 60, 90 triangles or 45, 45, 90 triangles, the lengths on those can change as long as we keep the same ratios, but the angles never change. You apply the law of cosines to a right triangle. So let's say that means that angle C is a right triangle, which means it's 90 degrees. And cosine of 90 degrees is 0, which means you end up with C squared equals A squared plus B squared minus 0, because 0 times 2AB is still 0, which means you end up with A squared plus B squared equals C squared, which is the Pythagorean theorem. So that's kind of a neat little proof about the Pythagorean theorem and how we get the law of cosines from that.